Okay, so now we're going to move into our discussion of connective tissue. We've already talked some about this in lab and how to identify it. But let's go through this a little bit more. We're going to start with the first major category of connective tissue, which is connective tissue proper. And keep in mind there's two major subcategories, loose and then dense, and within those there are then three specific types for each of those. Okay. So what you may notice on your notes packets, okay, is that you have these charts, and these charts are there to help you really understand what are the differences in each of these types of tissues. Now, if you look back into the book, you're going to notice that there's lots of different figures here to help you. So there's this type of figure, and notice the title. It says the cells and fibers of connective tissue proper. So here is where all of the cells and fibers that you could ever find in connective tissue proper is. But let's say that we want to know a little bit more about a specific type of connective tissue. Well, here's some other figures. It can give us its locations, it can give us some of its functions. So this is an excellent place to look for that. Okay, and then another place that you may want to look for is then once you've looked at some of those figures, then go through this text and skim it until you see some information. So if you're looking for, notice on your notes packet it says list the cells within the connective tissue. Well, we look under areolar tissue and it says it may contain all the cells and fibers of any connective tissue proper in a very loosely organized array. So if we're looking for the specific cells, it can contain all the cells and fibers. Well, remember back on an earlier page it listed the cells and fibers of connective tissue proper. And so what we would want to do is we want to look at this image. We might want to look at some of the headings, connective tissue proper cell populations, and then list each of the cells that would be there. So for example, for areolar connective tissue, we're going to have pretty much all of them. So melanocytes, macrophages, mast cells, lymphocytes, microphages, fibroblasts, fibrocytes, adipocytes, and mesenchymal cells. So we end up having almost all of the cells here. Now the fibers, they're going to have all. Hopefully you remember from lab that we had three types of fibers, elastic, collagen, and reticular. And so here again we're going to have, it says it has all of them, so elastic, collagen, and reticular. And so we end up having all of those fibers in the tissue for areolar tissue. Now again, you can go back here to these charts, and this is going to tell you locations, it's going to tell you functions, and you may notice, actually I think it's on 129, here it says it contains fibers in a very loosely organized array. So when we go here it says are the fibers loosely organized, or in parallel sheets we're going to put loosely arranged. Okay. And so this is just an example of how you would start with areolar tissue. Areolar tissue is very common. It's found all over the body, and it's really kind of a packing material. It just helps glue things together. So I'm going to take you through and fibers, find a few things that are a little bit maybe counterintuitive. So adipose tissue has very few, if any, fibers. So very few, if any, fibers. Okay. And so if they are there, they're going to be loose, but a lot of times that may not even apply. Okay. reticular cells, the main fiber there, or reticular tissue, is going to have reticular fibers. Okay, this is going to be found in the liver, kidneys, spleen, lymph nodes, bone marrow, and the function is really going to be specific to the tissue where it's located. Again, it's a loose array. Okay. Now, one thing that I want to make sure that you know up here, it says which cell usually makes the fibers found in connective tissue proper. And that is going to be a fibroblast. Okay, so keep that in mind. If you go through here and say the text or the figure doesn't list a cell, if there's fibers, there has to at least be this cell. So keep that in mind as you do that. Okay, and so again, if you're looking for similarities and differences, well, we go column by column according to the pairing. So here we have areolar tissue and adipose tissue. We are looking for a similarity. We know it's not fibers. It turns out that adipose tissue, it has mainly adipocytes. So the types of cells, well, they both have adipocytes. So that could be a similarity. If you look in the tables, you'll find that the locations and functions are unique. And so the other main similarity is that they're loosely arranged. And so a loose arrangement of fibers. Okay. Then they end up having a lot of differences. Okay, so adipose has very few fibers. It has mainly adipocytes and no other types of cells. And it has very few fibers. Okay, and so then you could also look at locations and functions and put that in a differences place as well. Okay, so you have the text, you have the homework, and so my suggestion is to use that and fill in your notes from here and see if you can find the cells, fibers, locations, functions, and then contact your instructor if you're having trouble with that. Okay. Then the next thing we want to go to is we want to go to dense tissues. Again, this means that, and I think this part needs to be reworded here, so I would reword this instead of saying are the fibers loosely arranged or in, I would say in dense parallel sheets or dense non-parallel sheets. So we really need more choices there for that. Okay. So again, all of these have fibers. Dense regular is going to have mostly collagen. Dense irregular is going to have mostly collagen. It will have some elastic. And then elastic tissue, it's going to be predominantly elastic fibers. Okay. If we have fibers, then what does that mean about cells? Well, that means we need to at least have fibroblasts within all of these tissues, because we can't get a fiber unless a cell makes it. Okay, so locations found in the body. Well, and actually one thing I want to say, so dense regular, these are in dense parallel sheets. That's how the fibers are arranged. Okay, and so what that means is that means you can pull on them from one direction and it gives you great strength. Now if you pull in many directions, it's not going to have strength unless you're pulling on it parallel to the fibers. And so basically the function is it's going to resist forces or pulling from one direction. Okay, or in one plane. Locations found in the body. The big thing is anywhere you have a tendon or a ligament, this is going to be made out of dense regular tissue. The difference in dense irregular is that they are found in dense organizations but non-parallel sheets. Okay, and so what this means is that you have a lot of collagen there that gives you strength, but they resist forces from many directions. Okay, so if we look at an image of this, images of the dense tissues. Let's see. Okay, here we go. Okay, you notice here you can see these dense fibers are all going from the top to the bottom. This is dense regular. Whereas underneath we've got dense irregular, and some of the fibers are going this way, some are that way, some are the other way. And so again, these you have to pull on them from either end, and they're very strong, but if you pull sideways, they don't have the same strength. Dense irregular, on the other hand, you can pull from this way, and there's going to be at least some fibers there to resist the pulling. Or you could pull that way, or you could pull this way, and so that's what's very important about the dense irregular connective tissue. Let's see. The other thing about the elastic tissue, it's also going to be in dense parallel sheets. And remember, elastic is our fiber that's like the spring, so you can pull it and it springs back. So because it's dense, because it does have other fibers besides elastic, it's going to be very strong, but it's a bit springy. It has some give. Okay? And so some of the places that we're really going to find that's important, some of our large arteries that experience high blood pressure, they have to have some give, but not be weak, so that whenever they experience that heart and it beats and it pushes blood through at high pressure, it can give and then go back to its original size. We don't want it to be stretched out either. So we're going to have it between large arteries. It's going to be below transitional epithelia. We're going to have it between our vertebra. We're going to have other things between our vertebra, but we will find it there. And so those are some of the major places that we find it. Again, I would encourage you to go through these pairings and look at each one and say what's similar and what's going to be different about each of these tissue pairings as you go through them. And so, I believe that takes us through that. Here's some practice, okay, to help you think about what some of these different cells do. Again, here's the labeling of the cells, some sorting to make sure you have these categories correct, and then matching some of these tissues with what their functions are.